Welcome to lecture 112 of digital electronics. In this lecture, in the previous lecture, that is lecture 111, we have dealt with introduction to finite state machines. In this lecture, we are going to deal with how to form Moore and Mealy machines of memory elements. Okay. So heading is Moore and Mealy models of memory elements. Yeah. So generally in a sequential circuit, the memory elements available are flip-flops. In any sequential circuit, the memory elements available are flip-flops. The available flip-flops are D, T, SR and JK. So here I am going to explain how to form the Moore and Mealy model of D flip-flop, Moore and Mealy model of T flip-flop, Moore and Mealy model of SR flip-flop, Moore and Mealy model of JK flip-flop. So we will start with D flip-flop. D flip-flop. Okay. So if I am having the excitation table of D flip-flop, having the excitation table of D flip-flop, how would it be? We are having present state, then D is the input, then what is the next state? So I can have 0 0 0 1 1 0 and 1 1. Next state is the input D itself, that is 0 1 0 1. Okay. So here what I can write, the next state, that is Qn plus 1. Qn plus 1 is equal to D itself. Now, how will you form the Mealy model? That is the question. How will you form the Mealy model for D flip-flop? Okay. See here, for a D flip-flop, there are two states. What are two states? 0 and 1. So first I am drawing the two states, 0 and 1. Now, here, if input is 0, what happens? Okay, if present state is 0 and input is 0, what is the next state? Next state is 0. That means if present state is 0, D is 0, what happens to the output? Output is also 0. Okay, so it will come back to the next state 0 itself. That means here, if I am giving 0 bar 0, that means present state is 0, input is 0, then the output is also 0. Now, in that case, I am giving input as 1. When input is 1, output is also 1. If input is 1, the output is also 1, but output is, if you are taking the output, that will become the next state. So you will get 1 bar 1. Now, at 1, what happens? If input is 0, at 1, if the input is 0, it will come back to 0. That means here, if the input is 0, output is 0. Input is 0, output is 0. Whereas at 1, if the input is 1, what is the next state? Output is 1 and it will come back to that state itself. So here what we have is 1 bar 1. So that is the Mealy model. Now coming into Moore model. How would it be? We are having two states, 0 and output 0 for D flip-flop. 1 means my input is 1 means my output is 1. Okay. Now, here what happens? Here, at 0, when it is 0, it will remain in that state itself. That is when input is 0. Whereas, if it is 1, it will go to this state. Now, when input is, now here, when the state is 1, when the input is 0, it will come back to 0. Whereas if the input is 1, it will remain there itself. This one, it will remain there itself. Okay, that is the Moore model. And if you are drawing the state table, how did it look like? You have present state, next state and output, then input. What is input? Input I am having x. So when input x is equal to, or d is equal to 0, here d is equal to 1. So present state is 0, 1. If present state is 0 and input is 0, what is the output? The next state is 0. The next state is 0 and output is also 0. So it is 0 bar 0, 0 comma 0. Now when present state is 0, input is 1. That is the case. When input is 1, what is my output? Output is 1. And what is the next state? Next state is 1 and output is also 1. Now coming to the present state 1. When present state is 1 and d is equal to 0, what is the next state? Next state is 0. What happens to the output? For the d flip-flop, the output is also 0. Now coming into 1 with the d is equal to 1. D is equal to 1 means what happens? Next state becomes 1 and the output also becomes 1. Okay. So that is a state table. Okay. So hope you have got the difference between melee model and Moore model. Now coming to second part, second flip-flop, that is T flip-flop to form the Moore and melee models. Coming to the T flip-flop. Okay. So first I am drawing the excitation table. So I am drawing the excitation table. So if I am drawing the excitation table, how will it be? Present state will have input as, here input is T, and what is the output? That is the question. So you are having 0, 1, 1, 0, 0, 0, 1, 1, 0 and what? 1. Okay. If input is here, if the value of T is 0, there is no toggling. So here 0 is coming here, here we will get 1. Here what happens? Here toggling happens, so present state becomes 1 or next state. Now here what happens? Next state becomes 0. Okay. So that is basic. That is the basic excitation table of T flip-flop. That is Qn plus 1. Okay. Now if I am writing the expression for Qn plus 1, okay, in terms of Qn, how did it be? So this is basically, we can write it as XOR gate. So we can write Qn plus 1 is equal to T XOR Qn. Okay. Just 0, 1, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0. That is basically XOR gate. Now coming into melee model. Coming into melee model, how will it be? You are having two states, that is 0 and 1. Having two states, that is 0 and 1. Now, if it is 0 and input is 0, what is the output? Input is 0, output is 0, and it will come back to the next state. Next state is 0 itself. So it is, here we get 0 bar 0. Now, when the present state is 0, input is 1, output is 1, but what happens? The next state is also 1. So here we get 1 bar 1. Now, if input is 1, if present state is 1, input is 0, what is output? Output is 1 itself. That is the next state only. So you will get input is 0 and output is 1. We will come back to the state itself. Now coming 1 bar 1. That means present state is 1. Then you will get input is 1. So what happens? Output becomes 0. But here output is the next state itself. So you will get. So here what we can write, this is 1 bar 0. Okay. So that is the melee model. Now let me form the Moore model. Now coming into Moore model. Okay. So here we are having two states, that is 0 and 1 only. So 0 only if the output is 0, 1 only if the output is 1. Now here what happens? When it is 0 and input is 0, okay, it will come back to 0 itself. Okay. Here when the input is 1, it will go to 1. Here again, if input is 0, it will remain in 1 itself, and here if it is 1, it will come to this state. Okay. So that is Moore model. Now, if I am drawing the state table, of T flip-flop, how would it be? Let us check. So here I am having present state, then next state, comma output, then input X, or input here it is T. Okay. So here what happens? T can be equal to 0 or T can be equal to 1. T can be equal to 0 or T can be equal to 1. So present state can be 0 and 1. If present state is 0 and T is equal to 0, what is the next state? Next state becomes 0 with output 0. Here what happens? Present state is equal to present state is equal to 0, T is equal to 1. That means it will get toggled. Okay, so next state is 1 with the output 1. That's it. Here again 1 means, and T is equal to 0, you will get 0 comma 1 comma 1. You will get 1 comma 1. There we will get 1 comma 1. Okay. Here we get 0 comma 0. So that is the state table of this. Okay, that means if you are explaining the state table, present state is 0, and if input T is equal to 0, you will get the output as 0, and next state becomes 0. When T is equal to 1, what is the next state? Obviously next state is 1, and what is the output? Output of the T flip-flop in that case becomes 1. If present state is 1, here what happens? When T is equal to 0, obviously present state is equal to next state. So you will get 1 here, and what is the output? Output is the next state itself, that is 1. So that is how we are explaining the state table. So we have obtained the Milli model and Moore model and the expression for T flip-flop. Now coming into SR flip-flop. Okay. Coming into third one, that is SR flip-flop. SR flip-flop. In SR flip-flop, what is the case? See, in SR flip-flop, what happens is that when S is equal to 0 and R is equal to 0, present state is equal to next state. That is no change. Whereas S is equal to 1, R is equal to 1. That is an invalid state. Okay. So here the invalid state is not considered. Invalid state is not considered while forming the state machines. Invalid state is not considered while forming the state machines. So now I will draw the excitation table. Okay. If I am drawing the excitation table, I am having present state, inputs. There are two inputs. Which are they? That is S and R. And what is the output or next state? Next state. So here I am having 0, 0, 0, 0, 0, 1, 2. Then 3 I don't have. So I can stop here. 4, that is 1, 0, 0, 5, and 6. 7 is not there because that means 1, 1, 1. That means when S is equal to 1, R is equal to 1, that two states are not there. Okay. Now, here, if present state is 0 and S is equal to 0, R is equal to 0, present state remains as next state. Here reset, it is 0. Here it is set, so it becomes 1. So S is equal to 0, R is equal to 0, there is no change, that is 0. This is reset. So 1 will be resetted to 0. Now here what happens? It is set. So 1 will be set to 1. So that is the next state. Now coming into the Milli model. Okay. Here I am having two states. Which are the two states? 0 and 1. 0 is state and 1 is a state. Now coming back. Now if input is 0, 0. If input is 0, 0, what is the output? 0. Okay. If input is 0, 0, the output is 0, that becomes the next state. Okay. So it is 0, 0, the output is 0, that becomes the next state. One more case. If S is equal to 0 and R is equal to 1, that means 0, 1. output is 0, okay, and the next state is also remaining as 0. So we can write as 0, 1, bar 0. Now, when S is equal to 1, R is equal to 0, that is 1, 0, the output is 1. That means the next state is 1. So you can go like this, that is 1, 0, bar 1. Now coming to 1, if it is 0, 0, no, sorry, there is some mistake in the state table. See, here what happens is that set and reset is equal to 0. Set and reset is equal to 0 means there is no change. That means 1 will remain there. Okay. Now, if S and R is equal to 0, what is output? Output is 0. Sorry, if the present state is 1 and S and R is equal to 0, what is the output? Output is 1 and that is equal to next state. So you can draw like this. That is 0, 0, bar 1. Then one more case. If it is 0, 1, output is, if it is 0, 1, the output is 0. Right? If it is, yeah, if present state is 1, okay, if present state is 1 and this is the case, so we will get 0, 1. What is the output? Output is 0. So it will go to reset. So it is 0. That is here what we will get. Here what we get is set 0, 1, bar 0. Here there is one more case. Set. That is 1, 0. The output is 1. So it is 1, 0, bar 1 here. Okay. So that is the melee model. Now if you are going for the more model, let us see how it looks like. Okay. So here what I am having, state with output 0, 1 with output 1. If it is 0, what happens? When set and reset is 0, it will remain there itself. Again, here also what happens? If it is 0, 0, it will remain there itself. Here also if it is 0, 0, it will remain there itself. And again, it will come back to 0 if it is 0, 1. Here you will get 0, 1. Then what is the difference? Here you will get 1, 0. Now, here that means, now coming into 0, 0 and 0, 1 is odd. Now, coming into 1, 0, 1, 0, it will go to next state, that is 1. So here you will get 1, 0. Then here 0, 0 and 1, 0 is over. So 0, 1 it will go back. 0, 1 it will go back. Okay. So that is the basic Moore model. Okay. Hope you have got the difference between melee model and Moore model. Now if I am drawing the state table of this SR flip-flop, so I am drawing the state table, how will it be? That is the question. I am having present state, and I will go with next state and output with inputs as S and R, one set of inputs. Here you are having 0, 0, SR, that is 0, 1, SR, that is 1, 0. Okay. So present state is 0, 1. If S and R is equal to 0, what happens? There is no change. That means next state is 0, output is 0. If this is reset, that is 0, this is also 0. And if set is 1, the next state is 1 and the output is 1. Okay. Now here 1, set and reset is 0, so you will get 1, 1. So here you will get reset. So 0, 0. 0, 0. Now set is 1, so you will get 1, set is 1, 1, what is the output? Output is 1. Okay. So that is the state table of SR flip-flop. Now coming into the last one, that is JK flip-flop. Coming into JK flip-flop. Now coming into JK flip-flop, what is it? Okay. So let us draw the excitation table of JK flip-flop. Excitation table of JK flip-flop. So there we are having present state. Then inputs I am taking it as J and K. Inputs, that is J and K. Then what is the next state? So what I am having is the next state. So 0 0 0 1 2 3 4 5 6 and 7. So this I will divide it in 4 by 4 pattern. Okay. Now here when present state is equal to 0, J and K is equal to 0, present state will remain there. 0 1, it is reset. 0 1 0, it is set. That is 1 1 1, it is toggle. So you will get 1. If J is equal to 1 and K is equal to 1, it will act as toggle. That means next state will be the complement of present state. 0 0, present state will remain there. 0 1, that is reset. So 1 will be resetted to 0. 1 0, that is set. That is 1 remain there. 1 1, that is toggle. So 1 will be toggle to 0. Now let us go with the melee model first. Go with the melee model. Okay. So we are having only two values, that is 0 and 1. We are having only 0 and 1. Now if input is 0 0, what happens? In the case of 0 0, if input is 0 0, output is 0 and it will come back. That is, here you will get 0 0 bar 0. Here what happens? 0 0 bar 1. Right? Yeah. So we get 0 0 bar 1. Now what is 0 1? 0 1 means it will be resetted to 0. Okay, that means it will be resetted. That means the state is 0 itself. So that is 0 1 bar 0. So here what happens? If it is 0 and 1, it will the state is 0 and the output is 0. So if I am taking here, you will get like this. That is 0 1 bar 0. Okay. Now these two 1 2, these two cases or these two cases or. Now coming to 1 0. If it is 1 0, next state is 1. That means output will be 1. So this is 1 0 bar 1. Now coming into here 1 0, you will get 1. So it is you will get 1 0 bar 1 here. Now coming into, that is these two cases are over. Now coming to these two cases. If it is 1 1, if it is 1 1, here the output will be 1. So that means here you will get 1 1 bar 1. Here you will get 1 1 bar 0. Okay. So that is basically the melee model. Now let me come into more model. Come into more model. Yeah. So in more model of JK flip-flop, you are having what? You are having two states. That is state 0 with output 0 and output. Yeah. This is 1 by 1. Okay. So because you are having how more model is specified, that is state bar output. If it is 0, output is 0. If it is 1, the output is 1. Now look to the 0 state. If J and K is 0, it will remain there. If J and K is 0, it will remain there. Here also if it is 0, it will remain there. Okay. If it is 0 1, again it will remain there. Okay. So here if it is 0 1, it will go to 0. 0 1, it will go to 0. Now coming to 1 0. 1 0 to go to 1. Here 1 0 to go to 1. Here 1 0 it will remain in 1 itself. Okay. 1 1. 1 1 means it will go to 1. That means here 1 1. Here 1 1 means it will go to 0. Okay. So that is basically the more model of JK flip-flop. Now if I am drawing the state table of JK flip-flop, coming into state table of JK flip-flop, okay, we are having present state, next state comma next state with output. So I am having J K J K J K J K 0 0 0 1 1 0 1 1. That is the values of J and K. Present state is 0 and 1. Okay. If it is 0, what happens when j is equal to 0, k is equal to 0? What happens? There is no change. So next state is 0 with output 0. 0 1 means in 0 0. Right? Yeah. If j is equal to 1, it is 1 with the next state with 1 1. Yeah. If j is equal to 1 and k is equal to 1, it is 1 comma 1. Now again, if j is equal to 0, k is equal to 0, here what happens? Next state is the process state itself, so that is 1, and output is remaining as 1 itself. 0 1. 0 1 means it is reset, so it is 0 comma 0. 1 0 means it is set, so 1 comma 1. 1 1 means it is toggled, so it is 0 comma 0. Okay, so that is the state table of JK flip-flop. Okay, so in this lecture we have dealt with formation of Moore and Mealy machines for memory elements. So we have formed Moore and Mealy models for D flip-flop, T flip-flop, SR flip-flop, and JK flip-flop. Okay, so that is all regarding this Moore and Mealy models of memory elements. Yeah, thank you.